Question 31. A financial analyst at a technology company is evaluating the risk profile of a new investment product using historical data. The analyst is considering applying a resampling technique to estimate the distribution of potential returns. The analyst debates whether to use Monte Carlo simulation or bootstrapping for the analysis. Which of the following statements about bootstrapping is correct? A. Bootstrapping requires the data to be independent and identically distributed. While these are nice things to have for data in pretty much any scenario, it's not going to be required for bootstrapping. So we can go ahead and rule that out. B, in bootstrapping, data must be resampled without replacement to preserve statistical integrity. This is key here is without. It actually requires resampled with replacement to preserve statistical integrity. So we can rule out B as well, since that will not be correct. C, bootstrapping can only be applied to data that is normally distributed. We can rule that out as well. This is actually a big advantage of bootstrapping, is that it can be applied to different types of distributions. It doesn't need to be normally distributed. So that leaves us with D. Bootstrapping involves resampling with replacement from the original data set. So just like we said in B, it does involve with replacement. Answer D. Question 32. Multicollinearity occurs when several variables can significantly explain one or more independent variables. Which of the following is most likely to be true about multicollinearity? So essentially what this is saying is it's when we have multiple independent variables that kind of overlap in what they explain about the dependent variable. So it can lead to kind of not exactly accurate statistical inference or in what we get from our results. So let's take a look at these. So A, multicollinearity does pose technical problems in parameter estimation and data modeling. So we're going to be able to rule this one out. So it can pose technical problems in the parameter estimation, but it doesn't necessarily affect the data modeling. It can make the estimates of parameters unstable and unreliable, but it's not distorting the model itself. B, when there is multicollinearity in a model, the coefficients tend to be jointly statistically significant. This is likely going to be our answer. And essentially what it means is there is going to be like overlap in what the coefficients are proving out for that independent variable or for the dependent variable. So an example is if we use two different employment indicators in the same model. So say we used an unemployment rates in some state or region of the US. So we use the employment in California, and then we also use the unemployment in the US as a whole. Well, those factors are probably going to be kind of explaining the same types of economic movements in variables. So they're going to be kind of jointly statistically significant because they're kind of measuring a similar or same thing. C, multicollinearity can be detected using the variance inflation factor, where a variable with high VIF is considered for inclusion in the model. So we can rule that out because a high VIF would mean we may want to exclude it from the model. So we can rule out C. And then D, multicollinearity ensures the model is unbiased and provides precise estimates of the coefficients. It does not ensure this. It's telling us which variables are essentially kind of correlated with which of the independent variables are kind of correlated with each other. So we will stick with answer B. Question 33. A portfolio manager is considering purchasing a bond with a face value of $1,000, a coupon rate of 5%, and a maturity of 5 years. Which of the following statements is most likely correct regarding the bond's price and yield if market interest rates increase? So if rates go up, what's going to happen? The bond's price will increase. Yes, it will. No, it will not. If rates go up, rates are inversely related to prices, so then prices will go down, and its yield will decrease. So the yield's going to go up. If the rate goes up, yield will go up. B, the bond's price will decrease. Yes, and its yield will increase. That's also going to be correct. So it looks like B will be our answer. And then C, the bond's price and yield will both increase. Price will not increase, yield will. So we can rule out C. And then for D, the bond's price and yield will both decrease. Yes, price will decrease and yield, but yield will not. So we can rule out D. And so let me just pull in a quick example to kind of demonstrate this. So the example, currently our yield is 5%. So if the market, that's our market interest rate. So our market interest rate is 5%. If our market interest rate goes up to 6%, this bond that is paying a 5% coupon, so $50, the new price of that bond is going to have to fall so that our yield on that coupon is 6%. So we do 50 divided by X equals 0.06. So the price of that bond is going to fall to $833 to fall in line with that new market interest rate. So rates go up, prices are going to decrease, and because rates went up, the yield on this bond is now 6% as well. So yields will increase. Price goes down, yield goes up. Answer B. Question 34. An intern in a risk management department of a bank is struggling with the understanding of the nature of credit ratings provided by the rating agencies. He overhears a discussion from some of his colleagues regarding the recent downgrade of company XYZ by S&P from A to BBB. What is the interpretation of XYZ's credit rating downgrade from A to BBB? So we've got A, bonds issued by XYZ are currently overvalued in the market. A credit rating downgrade doesn't necessarily have anything to do with over or undervalued in the market. It could have something to do with the business of XYZ, or it might just be related to their debt load and or something else of that nature. So I think we could rule that out. It doesn't imply overvaluation. B, stocks of XYZ are expected to underperform the market benchmark in the nearest future. We can rule that out too. Credit rating has no kind of implications for equity performance. It could lead to greater performance if they're using more debt to kind of run their operations, then they're levering up. They may they may be making themselves higher beta and perform better in the future. Who knows? Answer C, XYZ's capacity to meet its obligations slightly deteriorated from extremely strong to very strong. So this is going to be incorrect as well. And so I think the technical definition of A rating is strong, not extremely strong, to adequate. So for BBB, it's considered adequate, and for A, it's considered strong, not extremely or very strong. So it looks like we'll be going with answer D. Let's make sure it seems correct. XYZ still has adequate capacity. Going back to C, that technical definition of BBB is adequate to meet its obligations, but now is more susceptible to a negative change in the business environment. This sounds good. I mean, it's going from A to BBB. BBB is still investment grade, so it likely is able to meet financial obligations, but is more susceptible to the business environment. Answer D. Question 35. An insurance company's financial statements contain the following information. So we've got premiums, claims, operating expenses, and investment income. The combined ratio for the insurance company is closest to. So this is going to be pretty straightforward, kind of just a matter of memorizing this formula. We're given all the information that we need for it. So our combined ratio is going to be claims plus operating expenses divided by premiums. So we've got claims of 65, operating expenses of 20, so we'll have 85 up here in the numerator, and then premiums of 120 in the denominator. Brings us to 71%, which will be right there. Answer D. Question 36. If the variance of the residuals is not constant across all observations in a sample, the regression is said to be A, leptokurtic. We can rule this one out. Leptokurtic is going to be related to the distribution of the observation. So when it's leptokurtic, it's going to have fatter tails. B, multicollinear. So just go back to that. So the tails is not really related to the kind of variance of the residuals. So we rule out for that reason. B, multicollinear. Again, this is not going to be related to variance issues. This is going to be independent variable related. So when independent variables are multicollinear, it means they're essentially correlated with one another. C, platykurtic or platykurtic. This is also going to be incorrect, and this is related to distribution as well, like leptocritic. And it's when the tails in the distribution are flatter than normal. And then D, heteroscedastic, this is going to be our answer. It's essentially defined right up here. It's when the variance of the residuals is not constant across all observations in a sample. So we'll go with answer D. Question 37. Cytadela Bank from Poznan, Poland needs to measure the yield of a coupon bond portfolio. One of the bonds in the portfolio has the maturity exactly equal to the term of a key rate, and the price of that bond is exactly par. How do the bond's yield and the key rate compare? So we've got they're identical. The bond's yield is higher than the key rate. The bond's yield is lower than the key rate. Or D, the bond's yield has no discernible relationship with the key rate. So the things that we're going to be looking at here to determine whether the yield and the key rate are the same or different. So big thing is going to be maturity and the price. So if we have price and maturity the same, then these should be identical. Where these would vary is, so to kind of level all this together, if they have the same maturity and the same price, then they should also have the same coupon. And so where these would potentially vary is if we had a different coupon coming in because of a different price, then that could lead the yield of the bond to be potentially higher or lower than the key rate. But since these are all the same, the yields on the bond and the key rate should also be the same. So we're going to go ahead and go with A. They are identical. Question 38. A Canadian lender intends to forecast the expected loss on a loan to a prospective mid-sized corporate borrower. As per the current estimates, the bank will suffer a 60% loss if the borrower does not perform the financial obligation. The risk measure is, so our risk measure is this 60% loss if the borrower does not perform the financial obligation. So what is this 60% loss measuring? We've got A, loss rate. That sounds like it could be our answer. The 60% loss is referring to the loss rate, it sounds like. So if the borrower does not meet their obligation, the bank is going to lose 60% of what they lent them. B, probability of default. We can rule that out. Probability of default would be would say something like the bank expects a 2% probability or expects a loss of 2% or something like that. But it's for this specific obligation, they will lose 60%. They're referring to the amount of money that they're loaning that they'll lose. Exposure at default. So this would be, we can rule that out too. That would be a specific number. So we don't have any number. We don't know how much they're lending them. We just know it's 60% of what they're lending them. But 60% of what? We don't have that number. And then expected loss. Expected loss is going to be a combination of probability of default and loss rate. So since we've already ruled out probability of default that we don't have here, we can rule out expected loss as well. And so we will stick with A, loss rate. Question 39. The stock price of Alpha Farm skyrocketed to USD 200 after a recent announcement of a drug approval by the FDA. Francesca Merck wants to quickly estimate the approximate price of her European call option on Alpha stock using the Black-Scholes Merton model. The call option has expiry in 3 months and a strike price of USD 50. If the risk-free rate is 8%, then which of the following is closest to the price of Merck's call option? So this is the formula we're going to be using here to calculate the value of the call option. The key here, though, is the call option is a strike price of 50, but we've got a stock price of $200. So the call option is significantly in the money since we're far above the strike price. So when that's the case, this call option formula is going to simplify. We can assume that ND1 and ND2 are essentially 1. So we're assuming that it's basically a 100% chance that we'll end up being in the money since we're so far in the money already. So this is going to simplify down to a more simple formula for us to calculate this from. which makes things a little more straightforward. So we're going to be taking the current price, which is this variable here, and then K is our strike at 50. And then we're going to be discounting that strike price using the continuously compounding variable. And our R will be 8%. T will be 0.25 due to the 3-month to expiration. So this is what that ends up looking like. We get 200 minus 50, and there would be make sure you put up parentheses here when you're punching it in your calculator. And when we work that out, we get 151, which corresponds right here with answer A. Question 40. An analyst covers 2 companies, Zila Limited and Yina Incorporated. Yina is a subsidiary of Zila. The probability that the return on equity of Zila exceeds 20% this year is 0.1, while the probability that the ROE of Yina exceeds 30% is 0.05 for the same period. If the probability that the ROE of Zila exceeds 20% and the ROE of Yina exceeds 30% is 0.02, so both of those events happening, then the probability that the ROE of Yina exceeds 30%, given that ROE of Zila has already exceeded 20%, is closest to. So this is going to be a conditional probability formula, or a conditional probability problem here. So given ROE of Zila exceeding 20%, given that that happens, what is going to be the ROE of Yina also exceeding 30%? And we're given 3 different probabilities here. So we've got Zila exceeds 20% at 0.1. So this is going to be involved in that formula, since this is something that needs to happen at the start. And then we have Yina exceeds at 0.05. So this is another given probability, and then the last given probability is that they both do. So for conditional probability, here's what that formula is going to look like. So we've got the probability of B given A. So in this instance, we'll say that B is the Yila exceeding, and then A is Zila exceeding. So we've got Zila exceeding, and then that's our A, and Yina is our B. So conditional probability of B given A is that the probability of both happening, which is given right here at 0.02. So that's going to be plugged into our formula right here in that numerator, and then we're going to divide that by the probability of A happening. So we assigned A of Zila, so ROE of Zila has already exceeded 20%. So that's where we get our A. So then that number is going to be right here at 0.1. So it's going to be 0.02 divided by 0.1. Pretty straightforward, gives us 0.2, which corresponds right here with answer A.